All things in the universe are created via the electron binding of atoms, and their basis is significantly affected by whether an electron is regarded as a substance or not. Modern physics does not regard an electron as a substance but as an ambiguous matter existing in the form of a probability weight, expressed using an orbital function based on the theory of atomic electron orbital functions. However, gaining a rational and clear understanding of electrons remains difficult. This principle considers an electron to be a substance and constructs noble gases, which contain the last atom of each period in the periodic table and remain in a gaseous form, as a three-dimensional structure, while considering other atoms to only exist through binding. In particular, the atomic structure of this principle is a basic element for constructing the molecular and nuclear structures. Atoms are composed of a nucleus and electrons. The atomic structure is in close relationship with the periodic table. The outer electrons of the last electrons in each period constitute the electron shell. Electron shell of noble gases is helium-2, neon and argon-8, krypton and xenon-18, radon and oganesson-32. A noble gas is in a form such that electrons are arranged in identically separated areas of the electron shell and is present by itself without combining with other atoms. Only noble gases have a fixed electronic configuration. The electrons are perfectly arranged around the atomic nucleus, and the atom circumference has a negative charge. Therefore, there is a repulsive force between noble gases, and they only exist in a gaseous form. Other atoms have an unstable electronic configuration. Consequently, they combine with other atoms to form molecular structures. Electron positions of the atoms of noble gases. Electron position of helium is symmetrically located with respect to the nucleus. These electrons dominate the surface of a hemisphere. Electron position of neon and argon are 6 sides of regular hexahedron inscribed in a sphere are expanded to the surface of the sphere to make the spherical regular hexahedron. The equator of this spherical regular hexahedron and longitudes perpendicular to the equator are drawn to divide the surface of the spherical regular hexahedron in 8 regions. The apex of a spherical regular hexahedron becomes the electron position and the electrons dominate each surface. Electron position of krypton and xenon are 3 electrons are located at the center of a geometrically identical area in 6 sides of the spherical regular hexahedron. These electrons dominate each surface. Electron position of radon and oganesson. If the surface of the sphere is divided into 8 equal parts, geometrically forming 4 equal areas, then the entire surface is divided into 32 equal areas, and for each divided area, an electron is located in the center and the corresponding electrons dominate each divided surface. The following explains the bonding and properties of the special atoms of each period, obtained from their atomic structure. Electron bonds of carbon atoms. Carbon is in period 2, group 14. It is an atom with 4 electrons in the outermost shell. When the carbon atom combines flatways in a lattice spaced out 1 by 1, it becomes graphite substance with the highest strength owing to its 4 covalent bonds. Moreover, when the carbon binding is formed in a 3-dimensional structure, it becomes a diamond, a substance with the second highest bonding strength. Electron bonds of aluminum atoms. Aluminum is in period 3, group 13. It is an atom with 3 electrons in the outermost shell. 3 electrons of an aluminum atom are located in the x, y, z directions of a spherical regular hexahedron. Aluminum is a light and strong metallic atom in period 3. Electron bonds of cobalt atoms. Cobalt is in period 4, group 9. It is an atom with 9 electrons in the outermost shell. 9 electrons of the cobalt atom are located in the x, y, z directions of a spherical regular hexahedron. Despite having a strong bonding, 3 electrons are not fixed and move around because of the effect of neighboring electrons. Thus, its strength is lower than that of chromium, which has 6 outer electrons. Cobalt is the basic atom for manufacturing magnets owing to the movement of electrons. Electron bonds of tungsten atoms. Tungsten is in period 6, group 8. It is an atom with 20 electrons in the outermost shell. 8 electrons of the tungsten atom are located at the apex of a spherical regular hexahedron, and the remaining 12 are placed in the x, y, z directions, respectively. Therefore, it is the strongest atom among metallic atoms. It is also the densest metal, with a constituent structure closely packed with electrons. The electron is a substantial material that exists in practice. Only the noble gases have a deterministic atomic structure. Just as the atomic and molecular structures of atoms and molecules have been determined on the basis of the classical laws of physics, the nuclear structures of atoms can also be created by certain laws. However, there is no equipment or method through which the nuclear structure of an atom can be determined. The nuclear structure theory was reasonably developed through intuition and can be utilized to explain various phenomena revealed by experiments. In particular, the phenomenon in which protons, electrons, and gamma rays are emitted after 2 neutrons undergo half-life decay and 1 neutron undergoes beta decay is important for atom creation. In this process, the collapse of the neutron is regarded as the division of quarks of the neutron, which is similar to the natural phenomenon of cell division. Furthermore, the source of all forces was thought to be the magnetic force, and the strong bonding between a neutron and a proton in the nucleus through the bonding of U quark and D quark was comparable with the electromagnetic force, which is the attractive force between a proton and an electron. The following is the concept of the strong force and weak force. The bonding of 1 alpha particle strengthens when U quarks and D quarks are alternatively arranged in one plane and the particle structure takes the shape of a square ring. This strong bonding imparts a strong force. Moreover, the shape resembles that of horseshoe magnets with the N pole meeting the S pole. In addition, the bonding between different alpha particles imparts a relatively weak magnetic force, which induces a weak force, and the particles acquire the shape of superimposing horseshoe magnets. The nucleus of an atom is composed of a neutron and a proton, and as the atomic structure is made of noble gas on the periodic table, the nucleus of an atom is also based on the noble gas. That is, the nuclear structure is closely related to the position of electrons when creating the nuclear structure with the fixed electrons of the noble gas atom. The nuclear structure is created on the basis of the basic units the neutron, proton, and electron. The neutron and proton are bordered on each other, while neutrons remain away among themselves and so do protons. The protons and electrons have the same 1-to-1 correspondence and orientation. The nuclei of neon, a period 2 element, are placed in both upper and lower layers of the nuclei of helium, and the electrons are located at the 8 apexes of a spherical cube, forming 1-to-1 correspondence with the protons. Four pairs of nuclei of argon, a period 3 element, are horizontally arranged in both upper and lower layers of the nuclei of neon, and the electrons are located at the 8 apexes of the spherical cube, forming 1-to-1 correspondence with the protons. 3 pairs of nuclei of krypton, a period 4 element, are placed at each of the 4 sides of the center as well as both upper and lower parts of the nuclei of argon, and 3 electrons are located at each side of the spherical cube, forming 1-to-1 correspondence with the protons. Three pairs of nuclei of xenon, a period 5 element, are placed at each of the 4 sides of the center as well as both upper and lower parts of the nuclei of krypton, and 3 electrons are located at each side of the spherical cube, forming 1-to-1 correspondence with the protons. Four pairs of nuclei of radon, a period 6 element, are placed at 8 apexes of the upper and lower layers of the nuclei of xenon, and 4 electrons are located at 8 apexes of the spherical cube, forming 1-to-1 correspondence with the protons. Four pairs of nuclei of oganesson, a period 7 element, are placed at 8 apexes of the upper and lower layers of the nuclei of radon, and 4 electrons are located at 8 apexes of the spherical cube, forming 1-to-1 correspondence with the protons. The number of neutrons in the nucleus is higher than that of protons in most atoms. The role of these additional neutrons is to help stabilize the nuclear structure and to form radioactive isotopes. The additional neutrons of the atomic nuclei of noble gases are as follows. The number of additional neutrons in oganesson is 58. The number of additional neutrons in argon is 4. The number of additional neutrons in krypton is 12. The number of additional neutrons in xenon is 24. The number of additional neutrons in radon is 50. If the source of the strong force, weak force, and electromagnetic force is the magnetic force also becomes the source of gravitational force. Modern chemistry can explain the phenomenon of atoms being bonded to become molecules with the concept of ionic and covalent bonds with the Lewis symbol, but it was difficult to understand triple bonds and think of the shape of molecules in 3 dimensions. This molecular structure theory regards an electron as a substance that is arranged around the atomic nucleus to clarify the ionic and covalent bonds. In particular, for atoms up to the 3rd period, the bonds of atoms, except for noble gases, which have perfect electron configurations, were explained in 3 dimensions using an 8-electron configuration and a 6-electron configuration centering around the nucleus, and the explanations are presented below. Modern chemistry, atoms that use noble gases up to the 3rd period of the periodic table combine with other atoms and bond with each other. There are 2 ways to make a molecule, 6 electrons and 8 electrons. 6-electron diagram is that electrons are located in the center of each of the spherical regular hexahedron around the nucleus of an atom, and when combined with neighboring atoms, a stable molecule is created. N2 N 1, 2, 3, 4, 5 N 1, 2, 3, 4, 5 CO C 1, 2, 3, 4 O 1, 2, 3, 4, 5, 6 NO HCN In this way, each atomic nucleus is surrounded by 6 electrons and becomes stable. The 8-electron diagram is a method of making most molecules, and when electrons are located at the 8 vertices of a spherical regular hexahedron through covalent and ionic bonds of atoms, the molecules bound to the atoms find stability. CO2 C 1, 2, 3, 4 O 1, 2, 3, 4, 5, 6 O 1, 2, 3, 4, 5, 6 H2O O 1, 2, 3, 4, 5, 6 1 H 1 H O2 O3 CaO CaCO3 C6H6 In this way, each atomic nucleus is surrounded by 8 electrons and becomes stable. It is a constituent of proteins, which make up the fundamental skeleton for living organisms. It is circulated through the generation by plants and subsequent intake by animals. There are 22 kinds of amino acids, and the 8-electron configuration and stereogram of the molecular structure are presented below. Alanine Valine Leucine Isoleucine Methionine Tryptophan Phenylalanine Proline Pyrrolysine Cysteine Glycine Tyosine Serine Asparagine Threonine Glutamine Lysine Histidine Arginine Aspartic acid Glutamic acid Selenocysteine Gas, liquid, and solid state according to the temperature of water molecules based on molecular structure theory. The process of ice formation by combining solid water molecules is as presented below. Molecule binding, water, liquid, gas, solid. When the oxygen atom receives energy and its temperature exceeds 100 degrees, the volume increases and the nucleus of hydrogen enters the outer shell of the oxygen atom. The resulting water molecule has a negative electric charge as a whole, and repulsion among molecules takes place. When the temperature of the oxygen atom is between 0 degree and 100 degree, the volume of the oxygen atom reduces and the hydrogen nucleus stays away from the oxygen atom at a moderate distance. It freely moves and consequently, the water molecule is fluidified. When the temperature of the oxygen atom is below 0 degree, the volume of the oxygen atom further reduces, the hydrogen nucleus recedes from the oxygen atom, and finally, it combines with another water molecule. 6 out of 12 protons of the hydrogen atom form the hexagonal water structure. 3 of them form a horizontal binding among hexagonal water molecules, and the remaining 3 protons form a vertical binding among hexagonal water molecules. I state due to the vertical and horizontal bindings of hexagonal water molecules. The shape and properties of all creations in the universe are determined by the binding of electrons.